4.
For RCR TV, I'm Sean Kinney, and welcome to the inaugural installment of our Speakers Series, which we host here at our studio space in East Austin, Texas. We've got a great program for you this evening. Let me introduce our guests. Down there on the end, we've got Franklin Flint, who is the Chief Technology Officer with TIA, the Telecommunications Industry Association. And next to me, we have Liam Quinn, who is a Senior Fellow and Vice President at Dell. So fellas, thank you so much for joining us this evening. Look forward to a really interesting topical discussion. And we prepared a little bit over email in advance, but essentially for our viewers at home, we're gonna take a look at some evolving technologies in the telecom space, namely 5G, the Internet of Things, and then Wi-Fi. And specifically, we kind of wanna look at how these technologies are going to likely intersect as they continue to evolve over the next few years. So before we really get into that, I was hoping we could start by just setting a foundation as it relates to 5G. Obviously, it's not yet been standardized. The R&D and the standardization work are going on in earnest, but I think there is some consensus on what some of the technological components will likely be. So if we could start, Franklin, just give us your take on what 5G, from your perspective, will be.
Well, 5G has a lot of components to it that go beyond just the wireless interface. But I think for now we'll talk mostly about that wireless interface, which makes the assumption that the science and the research will be there to deliver incredibly huge bandwidth. The ITU recently defined the top speed of 5G to be 20 gigabit per second throughput, and I believe the minimum speed is 1 gigabit per second throughput on that. So in order to call something 5G in the future, you'll have to meet those requirements and be within those limits. It'll require a lot of research in bidirectional communication. The MIMO interface has to be advanced even further, and that will enable more throughput as well as more devices on the network. And my friend here, Liam, will probably know quite a bit more about that than I will.
Yeah, so thanks, Franklin. So I think it's exciting, next generation wireless. We've been around this industry long enough that you see successive innovation across the wireless domain. I think in the 5G timeframe, which is 2020, it's not going to be a light switch at that time. I think it's going to be evolutionary between now and then. And I think you're going to see a lot of innovation in different parts of the wireless domain, like in Wi-Fi, in cellular, in licensed spectrum, unlicensed spectrum. And spectrum is going to be key in the whole 5G environment to deliver the bandwidth that Franklin talked about. But I think you're going to see a lot of innovation in things like antennas, smart antennas, and agile radio capabilities in order to allow devices to scale across networks, be it unlicensed or licensed spectrum, be it Wi-Fi, be it advanced in different standards like Wi-Fi, even 60 gigahertz white spaces, spectrum that's coming online, spectrum that's will come online in the future, as well as advances in the licensed spectrum area.
Okay, so those are some of the technological components. And now if you guys could each just sort of characterize what you think the transformative power of 5G will be in application. And I mean that both for enterprises and for me and for you and for consumers. What is it going to do to my life once we've seen 5G commercialized and become widely available?
I think it's going to be reflective of where the enterprise was over the last 5 years. So you had 10 megabits per second on Ethernet, then it went to 100, then a gigabit, and some applications multi-gig. And that's delivered over the reliable media like Ethernet. And in 5G, it's bringing that experience from the enterprise environment into a mobile environment so that you have that richness of experience with multimedia delivery, content delivery over a mobile device, leveraging multiple network capabilities. So it's not like you have to have all this buffering and so forth. I think it's going to really open up bandwidths and the delivery mechanism of richer sets of content to drive business economics, business usage user experiences both in the enterprise as well as in the consumer side. So I think that's the environment that's going to evolve in the mobile side of things.
Okay, and Franklin, what's your take on that?
Yeah, so I believe that's exactly right. I agree with Liam on all those points. I also see a lot of growth in the density of users on the network. We already have issue with when you have large congregations of connected devices in one area for a short period of time, running out of bandwidth, running out of capability to support that many users, such as here in Austin at South by Southwest or Austin City Limits Festival. We have to bring in extra connectivity to handle that. We have the small cell build out to try to handle that. But also, all of the historical wireless interfaces for broadband, for mobile broadband, have been geared towards outdoor use or vehicular use, not so much indoor use. So we all have encountered experiences where we're in a shopping mall or in a building or in our offices where we get terrible coverage, or the coverage is poorly performing because of so many people being in one area. That's going to have to be addressed. That density issue is going to be addressed with 5G in a lot of ways. Part of it is because of the amount of bandwidth that's available. You have less problems with sharing of spectrum and sharing of space, but also in the amount of spectrum that should be made available, especially when you start getting into the higher frequencies, like you talked about the 60 gigahertz and above. But also when you start looking at being able to move into Wi-Fi and into Bluetooth and Zigbee and other things for your sessions, I believe that's going to make a big difference to allow for greater density and better connectivity in the field, which is going to become more and more important as we start talking about IoT applications where you have hundreds of devices in a building needing to connect, where before you may have only had a couple. More like thousands of devices needing to connect, where before you only had a couple. And I believe that is a very interesting development that is going to be addressed with 5G.
Yeah, you guys hit on two really key sort of columns of 5G, the access to higher band spectrum, as well as the network densification. But that's something that we're seeing right now as a way to bolster capacity where it's needed for our LTE networks and even legacy networks. And I think IoT is a big part of that. We've all heard the projections that by 2020, there will be something like 50 billion connected devices on Earth. And these aren't all going to be smartphones. These are going to be objects around your house, like your refrigerator or your thermostat. It'll be your car speaking with other cars along the roads, and then speaking with the network that's run by your municipality or your country. So what I'm interested in as those two intersect, as we see the IoT start to take shape, before we fully realize what we can do with IoT, do we need 5G mobile networks to support it?
So I view it as, if you take a highway right now, you got multiple lanes on a highway. And if you think of 5G as maybe that same highway is 10x the width, with 10x the number of lanes on there. And the inside lane could be slow, the outside lane is very fast. Things like IoT, which is a lot of data, small data bits where you're monitoring the lights or the health of the AC or HVAC unit or other environmental issues and control systems, that can be data only. And it's not lots of data, it's small packets of data, and not all data has to move across the network. It may be buffered locally, analyzed locally, some action taken. It doesn't all have to move to the cloud. But when it does, it may be guided over spectrum that's specific for IoT or more preferred for IoT. So for example, IEEE 802.11af, which is the TV spectrum, for example, that's coming online more and more, sub 1 gigahertz. It's ideal because of its propagation characteristics for long distance. So if you want to get to a tower or another site, you can do that. Other standard like 802.11ah, which again sub 1 gigahertz, being targeted for IoT. So that could be used for small bursty type packets of data when that data needs to move from one location to another. On the converse, you could say for multimedia, where it's a lot of richness of data, high bandwidth capability, you can retarget that onto certain spectrum areas versus where the IoT is. So not all has to go in the one lane. I view 5G as multiple lanes in the existing highway that we have today, and then you can actually start to have smart devices or smart usage of spectrum to optimize the movement of content, be it packets and data only, be it multimedia, voice and data and multimedia. So I think you're going to see a lot of innovation in areas like that, and how devices can be agile in the use of spectrum that's available over multiple means. And I think that's where you're going to see the optimization of spectrum, but also the usage and the capabilities, because some data is latency sensitive, critical, mission critical, let's say for emergency services, whereas some I need to monitor the water flow, and maybe I can monitor that every 5 minutes or every 5 seconds or every 15 minutes. That's a big difference.
And Franklin, from your perspective, from TIA's perspective, what is that sort of intersection of 5G and IoT?
It's big and complicated. That's the big thing. IoT has become a buzzword that we throw around all the time, and just about anything that is a device that's connected, we're calling an IoT device. And that is true by the broad definition of IoT, but there are going to be specific applications that are going to need standards and guaranteed performance and guaranteed results, like vehicle-to-vehicle communications or monitoring of electrical grid systems, things like that, that are going to need to be able to be consistent and reliable, and we know exactly what to expect from that. And that tends to drive a need for clear standards, requirements that the standards be followed by the people providing them or using them. And some of that's already happened. I believe in the industrial automation space, there's been a certain amount of standardization that's already taken place there. As they move to wireless to communicate, they will develop or use existing standards to make that happen. In the vehicular space, that's all still under development. We're still figuring out how to do that. Because if you have an automated vehicle, a car driving itself down the road, it doesn't have any time to wait for a decision to be made if a child jumps in front of the car. That has to be instantaneous. Hopefully the car can stop itself, but needs to tell all the other cars it's stopping itself so they don't run into it. Mm-hmm. And that leads to a hard requirement on latency and things like that on the road. So I believe there is a need for some standards to be developed and for a requirement that people follow those standards. It's easy today for a startup to go and develop an IoT solution that works and gets the job done, that abuses the spectrum and everything around it, but because it gets the job done, people might buy it and implement it, and then the carriers are forced to find a way to work around that. And with the net neutrality rules that are coming into effect, it will be hard for them to control how that gets utilized.
But I think I want to just follow up on that point that Franklin talked about. I think there's two aspects here. One is, in the IT world that we're very familiar with PCs, desktops, notebooks, phones, and so forth, that's well understood. And there's lots of standards there across different wireless domains. In the IoT, it's the movement of that IT environment into an OT, which is operational technology, and that's very much a closed, proprietary environment, and they're starting to merge, and this is where the whole interesting evolution is happening in IoT. It's not going to happen overnight. There are no companies today that universally are developing standards for IoT. So you can't go down, like today, you can go down to a store and buy a Wi-Fi or a Bluetooth device, and you got a Bluetooth enabled notebook or tablet, or a Wi-Fi enabled notebook or tablet, and you know that they work. It's the guarantee interoperability. That doesn't exist today in the IoT world. And in the legacy world, there's a lot of what's called brownfield installation of protocols that, like RS-232, serial interfaces, FireWire, proprietary interfaces and protocols for both wireless and wired. And that's coming together into this IT world that's very much understood. So I think the whole standards for IoT is going to be more evolutionary. And I think there are a number of organizations that have been stood up over the last 24 months, and perhaps more to come. But if you look out there, there's like 140 institutions or alliances or standards bodies working on standards and they'll all claim that they're working on standards for IoT. But nobody is doing an interoperability or certification program for that. So I think that's evolutionary. And when you throw 5G on top of that, I think it's going to be a very busy, dynamic environment for the next number of years.
Franklin, I assume TIA, they do so much work on telecommunications and other standards. What's it look like for IoT standardization?
Well, the TIA started developing an IoT standard, a machine-to-machine standard, before IoT became the buzzword that we're using now, several years ago, and that came out of our TR50 committee. And that was the basis for the 1M2M standard that's being developed right now. It's an international conglomerate of standards development organizations that are developing that. And it's good work. I don't know that it solves all the problems that need to be solved. I don't know if it might be addressing problems that don't exist, but it's a start down that path. And I believe that as people start implementing and testing and doing interoperability testing and all that, the learnings that come from that will lead to more standards. And there are other organizations developing different kinds of standards, like the vehicle-to-vehicle communication standards. And I do believe that there is an opportunity to drive that. There needs to be some level of consensus, but there also needs to be more experience about what needs to be delivered and what can be delivered realistically. And as 5G develops, more stuff will come out of that I believe will lead to more. And I don't think a single standard will solve our problems. I believe there's going to be multiple standards for different applications and different requirements.
I think vertical markets. So what's happening in the industrial space may be one type of, or sets of standards. In retail it could be different, in consumer it could be different, in medical and so forth. So I think it's going to be unique for quite a while.
Yeah, well, I think that presents sort of an interesting dilemma, doesn't it, Liam? I liked your analogy of all the different lanes and a benefit to keeping certain types of technologies in spectral lanes and in standardization lanes. At the same time, though, we're moving very quickly towards 2020 commercialization of 5G, and presumably IoT deployments will only become more robust in the interim. So what are some of the risks associated with going down this path prior to standardization?
Well, industry moves along, products get developed, and you can't stop it. So, in reality, IoT has been around for decades. It was called embedded control systems, and the new buzzword is IoT, so everybody's jumping on that. Which is good because it's enabled by declining costs of silicon, sensors, higher levels of integration of embedded control systems, so it's really out in the mainstream right now. And it's moving more and more into the mainstream of IT. And you're going to see a lot of IT goodness moving into OT sort of legacy systems and learnings from OT into the IT systems. So you can't stop it, it's going to continue to evolve. And the more it evolves, I think the more it'll settle down. So we're in this like disruptive, dynamic environment right now, but I do think it's going to settle down in the next 18 to 24 months, where the pressures of business from a security, interoperability, manageability will start to push back on those innovators and developers of silicon, software, systems, and solutions to come up with more mature solutions. So I think that will help to level set the evolution between now and 2020. So 2020 is a target. It's not going to be that we just go like this and then suddenly 2020 is...
There's no light switch.
No light switch.
Yeah.
So we're on a journey, and it's at what part of the journey are you in from your company's perspective, from your employees' perspective, from an innovation or startup perspective, even standards. So we're on a journey, and different segments of the industry are in different parts of that journey.
Okay, well, as we continue on that journey, I'd like to hear from you gentlemen about how Wi-Fi is going to play a part. From my perspective, all of the connected objects at my house run off of Wi-Fi. It's good quality service, it's reasonably priced, but at some point is cellular going to supplant Wi-Fi? Is 5G going to be everything that it's promised to be, and that'll be our new sort of hub?
So the Wi-Fi industry is going to ship 3 billion solutions this year. That's double of what was shipped in 2012, which is 1.5 billion certification or certified products. So the trajectory continues to grow for Wi-Fi, and it's a global, well-recognized standard and logo around the world. It's in the unlicensed spectrum, both 2.4, which is very crowded, and then 5 gigahertz, and most of the evolution and innovation is happening in the 5 gigahertz band. Spectrum is like land. They don't make any more, and it's very valuable. Now, you can see that there's some interesting industry dynamics or changes happening, where you get LTE-U and LTE-LAA, which are one and the same. One is standardized or will be standardized versus the other. And that's the proposal to allow LTE, which is cellular radio interface capabilities, in the 5 gigahertz unlicensed band. So you can see that there's some parts of industry moving into this spectrum that's less crowded than over in the spectrum. So you're going to see a lot of this, I think, overlapping and bleeding over of different technologies being used in both licensed and unlicensed spectrum areas. Obviously, from a chipset perspective, you're going to see companies coming out with multi-radio capabilities that can operate either in a licensed band or an unlicensed band, based on the device saying, this is available to me today at this location, I'm going to jump on this lane. Versus this is more available as I drive down the block in my car, smart car, I'll jump on this lane. So I think you're going to see that transition between spectrum in the licensed space as well as unlicensed space by smart radios that are in development right now, will be in development and continue to be in development. That will enable mobile in devices, to allow that agility to select and transition multiple times as you walk, talk, get in a mobile environment, to move so that you have the best connection. Now, there's ways to enhance that you can actually measure the quality of the services available, and perhaps do dynamic switching across multiple carriers. Wouldn't that be interesting? As well as Wi-Fi. So, and then I talked about 11AH and 11AF. There are new spectrum areas coming in, and they will be part of Wi-Fi extensibility. And that will be added to the portfolio. So now you're getting this richer experience on in the Wi-Fi space, but I think it's not just going to remain, this is Wi-Fi and this is cellular. I think you're going to see, I've got a great experience on my device, and the user doesn't have to know which band they're on, or which area of the band they're on, or which lane within the band.
Franklin, where do you stand on that? Do you feel like we'll eventually just have a seamless blending of the two, that to the end user will not be noticeable?
I think that's the vision that a lot of people have. I think it's entirely possible technically to get there, because there is a lot of research going on in that area. There's a lot of the programmable radios, the programmable antennas that Liam's already talked about. And there's a lot of desire to get there because of the limited spectrum that's available, and the desire for the end user to have a good experience and not jump from carrier to carrier because they're having a bad experience in terms of the contracts. There are some issues on the carrier side on being able to deliver that to all of their users. Sometimes it's in the billing systems that they have in place. Sometimes it's in the contracts that they have to be able to connect to other companies' Wi-Fi networks and stuff like that. But I believe the goal is to get there, and I know that all the discussions around 5G include that. So it's not like there's a desire to ignore it and hope it doesn't happen, hope it doesn't affect us. There's a desire to reach the point where the end user just has a good experience, or the solution you're developing just gets the job done. And you don't have to worry about all that connectivity issues that we currently deal with. Like if I walk into certain places, I have to log on to Wi-Fi in order to use it, and I've lost my LTE signal because I'm inside a building. That kind of thing has to go away if we're going to have ubiquitous connectivity.
So just to add to that point too, you talked about Wi-Fi, we talked about cellular, but there's the whole service provider industry, like cable companies and other MVNOs and MSOs that deliver content into homes and residences and so forth. They're enabling a lot of their set-top boxes with Wi-Fi. Again, you could conceive over time that you could drive around a city like Austin, where there's so much Wi-Fi being used in homes and residences that you can transition across. So, for example, like Wi-Fi Passport certified allows that connectivity across carriers as well as Wi-Fi, and again, it provides that great experience as you're driving, for example. So I do think there's a lot of convergence happening simply because of bandwidth capabilities, latency requirements, power requirements that get transitioned into products over time.
Well, and this is where I sort of draw IoT in, particularly from a consumer perspective. If everything in my house is going to be on the internet, I would prefer it to be on Wi-Fi, because at current price structures, I'm not inclined to purchase a cellular plan for my shoes or for my light bulbs. So do you think that we'll see, in tandem with the emerging 5G networks, just a total reshaping to the business model that's applied to cellular?
I think for the home, again, when things are connected, it's like the smart coffee pot or the smart lights and so forth. There's other protocols out there that can serve those, like Zigbee or Z-Wave or Bluetooth Light, low energy. Very low bandwidth, very low power requirements, runs on a coin-style battery for years. So you don't need Wi-Fi for that. That's overkill. That's a sledgehammer trying to drive like a thumbnail. So I think you're going to see the addition and the use of some of those low power protocols for IoT specifically, and not have the need for Wi-Fi because of its cost and power in those applications. So I think we shouldn't lose sight of that either.
And relative to IoT, Liam, I was hoping while you're here you might give us just a brief overview of the work Dell is doing in that regard.
So our focus is on the commercial segment of IoT. And when you look at the assets that we have, it's not just about a sensor. We think of it as an ecosystem. It's an end-to-end delivery of an ecosystem for an IoT solution. And our initial target market is going to be in smart buildings. So we're working with a lot of partners right now. We're shipping gateways into the IoT space for smart buildings. We can pick up the sensory data coming off of HVACs and water utilities, meters and so forth. We have edge analytics through a number of our acquisitions that we've done over the last couple of years. We've got the security attributes that we have on the commercial side of our portfolio in those gateways, as well as manageability. We have the capability to move those over our network products into our data centers. We have the analytics in the data centers. We've also got parole systems from a services perspective, the back-end data centers. So we can go into partners and provide a complete solution. And where we don't have the components that we need, such as, let's say, sensors, we will partner with those based on the requirements that we need and the specs we develop around an IoT. So it is an end-to-end approach. It's not just one product and say, we've got a gateway, therefore we're in the IoT business. We go in there as a complete solution and deliver those.
All right, and to backtrack a little bit, Franklin, you and I talked about this slightly before we came on camera. Liam, you mentioned it early in our conversation. Utilizing white space for, I've heard it called super Wi-Fi, and just, you're able to take advantage of different propagation characteristics and extend the signal over a much larger area and don't have to worry about signal bouncing off of walls and things like that. Is that a viable technology that we're going to see to any appreciable extent in the near future? I've at this point just seen very limited, very academically geared sort of trials.
Yeah, so I'll talk briefly about that. Liam's a smarter guy on that topic, but we are seeing a lot of discussion about using the white space to get more available spectrum out there. Obviously, the regulatory bodies control how that stuff can be used and only allow it to be used in certain cases. So it's not a simple solution as saying we found a way to do something in the lab, let's go implement it.
Right.
You have to show that it can be done and it makes sense and it makes long-term sense. Because if you look at using like television spectrum, that's been assigned for decades, in some cases longer if you talk about radio band, FM radio, AM radio band. And a lot of those people feel like they have rights to those bands for as long as they're willing to pay for the contracts to have it. And for the FCC or another regulatory body to take that away from someone they've already sold it to is a challenge. Going to digital television freed up potentially a lot of spectrum, and they're now figuring out how to use that. They're about to have a 600 megahertz auction next year here in the US, and it'll be interesting to see how that works out. But how we accomplish that, I think I would defer to Liam more on that aspect.
Yeah, you said it, Liam. I mean, spectrum it's like property. They don't make it anymore, so it's a shame to see it sit there underutilized, but at the same time there are policy mechanisms in place that make it inaccessible. So how do you see that evolving over the next few years?
So a lot of that spectrum is dormant. It's not being used today in a lot of cities, and there are databases set up where a device can query the database to see if a TV station is in use, and if not, it can jump on that spectrum. And it's got great penetration capabilities, so it's certainly for long haul, backhaul for, let's say, IoT devices or meters and so forth, or even for broadband delivery into remote areas that don't have cable or other means to get a signal in there. So I think the FCC is being very proactive in their engagement with groups like the Wi-Fi Alliance, and certainly we're very much involved in the Wi-Fi Alliance in our position there, and working with the FCC on spectrum policy. And I think as the FCC leads, the rest of Europe and Asia will tend to follow, and they tend to follow the FCC's lead on that. So I think it will start to evolve, and it'll happen.
All right, well, as we wrap up here, I'd like to put one more question in front of you. This one's meant to be a little more fun, a little more speculative, but all the things that we've discussed this evening, down the line, once they're very much available and in use, how do you think your life will be different, Franklin?
Well, I've already become completely addicted to having the entire universe in the palm of my hand, in my coat jacket, everywhere that I go. I don't need to know any of the facts of history. I don't need to remember my grammar rules, any of that, because I have that available to me. But it's only available to me as long as I'm connected. And the idea that I never have to worry about connectivity again as long as I'm paying my bill, whatever that bill is and whoever I'm paying it to, is a very interesting proposition. Because once I can connect that kind of use of information, it can start being applied to everything around me. Right, I can start, my car can be connected and I can access it while I'm like, I can check, do I need to get gas before I drive downtown, or can I get downtown before I get dressed and leave? I know what time I have to leave to do that kind of thing. And that's really kind of small thinking, but it's going to make a big difference in my life. And I think it'll make a difference in a lot of people's lives once they start taking advantage of that. When you extend that to all forms of transportation, where I can plan a route to get anywhere in North America via connected devices, to connect to buses, to Uber or Lyft or Zipcar or bicycle rentals or trains or airplanes, you name it. The possibilities become pretty amazing, because you can plan your travel around expense, around time, around whatever fits your desires at the time. All of that becomes very fascinating to me, because I believe that knowledge and mobility are the two things that advance civilization more than most other things. And I believe all this connectivity, all this ubiquitousness that we will have will enable us to advance very rapidly. I don't think we'll recognize our schools in 20 years.
Liam, the same question.
So I think it's exciting. The whole technology space, the mobility space is even more exciting in some of those sectors. if you think today that you would have a phone that didn't have GPS, you'd be lost, So GPS 5 years ago really didn't exist, or if it did, it was very spotty, and now it's like mainstream. Cell phones, of the last 20, 25 years have really enriched our lives. So if you look at the rapid acceleration of some of these technology we talked about, some of these features that have enhanced our lives over the last 5 years, in the next 5 years it's going to accelerate even more. And as Franklin said, with a lot of sensor-based capabilities being put into all goods that are coming out in the future, like these lights will be sensor-based, these chairs will be sensor-based, so if there's somebody sitting here, the carpets, the doors, the lights and so forth, everything will be connected. And you'll realize when you look back in 5 years that, boy, we thought we were having a great time in 2015, but we can't believe where we are in 2020 or 2025. So again, it's this constant enrichment of what we have today, but it's even going to be more accelerated. And when you're coming downtown, you won't have to worry about a parking meter because your calendar knows where you're going and why you're going, and the address, and it's going to pre-reserve a parking spot for you near the place that you want to go, and allow you the right drive time or the best route to get down there. So a lot of the things we use will become smarter as part of our lives, and therefore our own personal lives will be more enhanced by that connected awareness or connected environment. And I just see it's like a white board, and there are very few dots on it 20 years ago, lots of dots 10 years ago, more dots 10 years ago, 5 years ago. What is it going to be in 5 years' time? Is it going to be fully filled in, or certainly more filled in than it is today? So it's just a constant enhancement of what we know today, but even more enhanced by capabilities, connectedness, and the enjoyment of using those devices.
Well, it really is an exciting time, and it's been wonderful to have a front seat and hear y'all's perspective on how this technology is evolving and how it's going to apply to us and as commercial enterprises, industry applications, all that. So I really appreciate you taking the time to speak with us this evening. To the folks at home, thank you for tuning in to our RCR TV speaker series.
Thank you.
Thanks.